All this vector space stuff is very weird. I miss the good old days of Rn, back when vectors could be vectors. If only there were a way we could go back. The good news is that there is. The bad news is that it's going to get even stranger. Let B be the set 1x x squared. This is a basis of P2. Importantly, this is an ordered basis of P2. This order is going to be critical. The vector 3 plus 2x minus 4x squared, written in the basis B, is 3, 2, minus 4, which is a vector in R3. We've discussed coordinates in the past, when we were discussing Rn, and believe it or not, this is the exact same concept. Compare 3, 2, minus 4 to the basis B, and the vector 3 plus 2x minus 4x squared. Notice every vector in R3 corresponds to a unique polynomial. This means P2 and R3 are isomorphic, or the same, and this is super powerful. It means any question we have about P2 can be restated as a question about R3, which we know a lot about. For example, is B prime a basis of P2? To figure this out, we need to compare this to a basis of P2, and let's use B because it's by far the simplest. Write each of the vectors in B prime in the basis B. We need the resulting vectors to either be linearly independent or span R3, and these two comments are really the same. Put them in a matrix and reduce. We see 3 pivots, so B prime is a basis of P2. As a fun exercise, you should write each of the basis vectors from B in the basis B prime. I find one to be this.